Good afternoon to all. We will start the session. Now, in this session, we will going to learn about what is the supervised learning and unsupervised. So, myself, Jitendra Vikram Temburne, I am head of the department at Institute of Information Technology, Nagpur. Today's contents, these are the contents I'm trying to cover because I got only 1 hour. After that, we are having a stress management session, which is a compulsory session at of Atal. So these are the content we're going to see: supervised learning, then basic concepts, evaluation of classification, which is very popular, then unsupervised learning, then basic concepts with respect to unsupervised, and we'll try to see how K-means algorithm can be applied, and then we will going to see the different representation of clusters. So I'm getting request regarding link. So here's the link once again. Okay, so the link is once again pasted. You can mark your attendance. Right? We will move towards the first topic, which is called as the supervised learning. Right. So before to start the concept of supervised learning, we want to see certain examples. So with that, we can get an idea how supervised learning and unsupervised learning help to solve the different problems. So here, the first example says that here what we want to do, there is some emergency room in the hospital, and what it does, it measures 7 variables such as blood pressure, age, and etc. for any newly admitted patient. This is the scenario. Fine. With respect to this scenario, what we have to do, we have to take certain decision has to be taken based on the particular scenario given in the first point. What we want to find, put it on whether new patient is intensive care unit patient or not. That we need to categorize, take a decision. The decision based on the 7 variable with respect to newly admitted patient, and then we have to take a decision whether to admit in the ICU, that is intense care unit. As we know that the intense care unit is the cost which is very high whenever anybody is getting admitted. So cost is very high per day. So here we have to take a correct decision, and we have to categorize, or we have to classify that particular patient, whether the patient is high risk or it is a low risk patient. Why? Because the intense care unit in the hospital, they are limited. That is the first thing, and moreover, the cost of that unit is very high. So by taking these particular variables in consideration, and by seeing the situation of the patient, what we have to do, we have to take a decision that whether the patient is high risk or low risk. So what exactly here we are trying to do? We are categorizing the patient. Yes. So if the patient is high risk patient, okay, so the model or the problem statement need to be get evaluated in such a way that it need to get categorized as a high risk patient. Okay, so then the intense care unit will be booked for that particular patient. This scenario where based on the data and based on the certain circumstances, we are trying to categorize the category of patient, whether it is high risk or low risk. Fine. Moving further, take a second example. Okay, idea really what kind of learning we require, whether it is a supervised or whether it is an unsupervised. Second example is like this: credit card company receives thousands of application of new cards. Okay, so most of the time we are getting a call from the company. They are saying that your credit score is very good, and we are offering a credit card to you. So how they are analyzing? They are having certain detail with them. So with that detail, they are making a call and they are promoting that particular card so that we can purchase it, okay, or we can have it. So here thousands of application is received by the particular bank or the credit company, and in that applications these many what we can say the data values are available, like age, marital status, annual salary, outstanding debt, and credit rating, and etc. So likewise these many parameters are there and they are helping us so that to take a kind of a decision at this particular instance. Problem over here, the problem is we have to decide whether an application should be approved or not approved. Yes, whether the person can get a credit card or whether a person cannot get a credit card. Okay, so here in this case the problem becomes the classification problem. Then that could be get categorized into approved or not approved category. Yes, approved or not approved category. So here once again we are categorizing a particular scenario. So in this case the scenario says that there is an application. So applicant will get categorized either approved or not approved. Moving further, based on these two scenarios, we have to take the help of machine learning, because machine learning is consist of different types of algorithms which so that we can do the categorization, we can do the classification and different kinds of tasks. Okay, first of all we'll focus on how machine learning works and where should be our focus. Fine. So what the that, like human learning from past experiences. So as a human, what we do, we learn from the past experiences. But the past experiences are not with respect to the computer, because machine learning will get implemented to a particular computer. Okay, so the computer don't have the past experience. Yeah. So with that, what we do, computer system learns from data. So in a computer, we have to supply the data. From that data, it can understand what is experience, what kind of data was generated in the past and what kind of data may generate in the future, that can be analyzed. Okay, so a computer system learns from data which represents some past experiences of an application. There will be a certain application domain. Let's say an example of that credit card. Okay, so if company is already having a certain database, okay, certain database where they have issued, they have approved the application or they have not approved the application, so that will going to become an experience. Okay, that will going to become an experience for the computer system, and it will learn from that data and it will approve or disapprove the application for particular applicant. Fine. So here in this case, our focus when we are talking in machine learning, because we want that the computer, we are thinking that the computer is having a brain. So we are, so to have that particular brain, we are writing we are having a model, and for that model what we are giving an enormous amount of data. So through that enormous amount of data, the computer need to be understand, the model need to be learned. Fine. So in this case, our focus has to be learn a target function. We have to learn a target function. Okay, that we use to predict the value of a discrete class attribute. So take an example, the example of credit card. In the credit card, how many classes we have? Only two classes. That is approved or not approved. So what focus in the machine learning, we have to learn a target function. Okay, so the job of target function is it will going to predict the value which will be either in the particular class. Okay, either in the particular class. Shared the link in the WebEx over here, so you can use this link. Fine, that Mr. Gaurav sir already have pasted on WebEx, so you utilize that link. Right. So now in this case, the cat can be approved or not approved, or in the case of patient who has to be get admitted in ICU, so high risk or low risk. So these are the classes. Already classes are known to us. Okay? And just we have to categorize when new sample comes or new data comes, belongs to this class or that class. So now in this case, whatever this particular job which we supposed to do, this task is commonly called as supervised learning. We are supervising, okay, that entire task, which is also called as a classification learning. So Now what we are having in this case, we are having the data, okay, that will be the labeled data. Then we are having the classes, okay, and what we want to do when any new data comes, so whatever the target function or whatever the model which we have, it need to categorize that particular data, process that particular data, and gives a respective class. Okay, that is the objective over here. So moving further, now here we want to talk data as well as the goal, because once you have the data, you have to think what you can achieve out of that data, what you can retrieve out of that data, how you can utilize that data. So now to understand that, let's say what the data is, it is a set of records. Yes, records. Generally, it can be a certain examples, a certain cases, case study data, or it can be a certain instances. Data can be generated with various ways, where sometime we can take a opinion, sometime we can write the questionnaires and we can share with the colleagues so that they can fill the data. So there are different ways, okay, to collect the data, and the data most of the time described by the attributes. In the data, we're going to have key attributes. So they can be A1, A2 up to AK. Okay. So simple example, let's say I want to gather the data of student. Okay. So in that I can consider the attribute student name, then the gender of the percentage likewise. So this will going to consider as an attribute. Okay. So these attributes later on you can use well towards to process. Fine. And then the data will going to have a class. Each example is labeled with a predefined class. Okay, so whatever the example data which has been recorded, they will be belongs to a particular class. Okay, that entire record. Now here, when you are having a data with the different attributes and the different class, now we need to identify what could be my, okay. So goal means a particular objective I want to achieve. So what we do in the goal, learn a classification model from the data. There will be a data, and that data will be fed to the classification model, and what that model will do, it will predict of new, it will predict the classes of new cases or instances. So that is all about whatever the new instance which we get. If I feed that instance, if I feed that instance to the classification model, of classification model is to predict whether it will be C or whatever it will. Moving further, now we will see another example. So in this example, you will get a more idea. This example is it. Okay, people are applying for a loan in a particular bank. Okay, so now this is the data the bank have. The attributes of that particular data is age, has. Voice is all clear. So I think now my voice is clear. Okay, if it is not, you can respond. If it is clear, you also respond for that.
Yes, it's clear, sir.
Yeah, thanks, ma'am. Thanks. Age, has job, own house, credit rating, and class. This is the see here the class which I was talking. So if you'll read the first row, which is a one record, so with respect to this class, no. That means the application of that particular applicant is rejected. He'll not going to get any kind of loan. Okay. So the particular bank or the organization who want to generate this data or you want to collect this data, he has to decide that what could be those parameters. So the parameter in this case, we are having a 4 parameters: age, job, own house, credit rating. Now this data is available with us, okay? Because without this data, I cannot design a classification model, and I cannot predict the class of the new data which will be supplied to the classification model. So what the objective over is, from this data we need to check whether it is approved or not, the loan application is approved or not, that we need to see. Yes, so for this we need not to do this, data will be get applicable or this data will be utilized for learning purpose. Okay, without learning get a kind of an experience which we required, and once we get that enough amount of experience, then by seeing the unseen data, by processing the unseen data, we can categorize the application either approved or not. Fine. So moving, let's say this is our data for loan application. Now we want to process this. What is over here is the task is the learning task. The moment you have the sufficient amount of data or the label data or the kind of a data on which you want to process, first job is you have to design a classification model. And the job of classification model is it will learn from the data. Okay, so just the data I have shown. From this data, the classification model will learn. That is the first step. Okay, and then after that, whatever the model which we have built, okay, from the given data, the next job is model will going to classify the future loan applications. So as and when in future any loan application comes, that will be feed to this classification model, and it will categorize whether it is approved or not approved. Okay, this is the way we are just classifying the data. So here supervised learning comes in picture. Now here there is a one question. The question is, what is the class of following case or instance? Now let's say this is the new data which we are receiving. Yes, this is the new data. Young, false, false, good. This is the new data, and now that we need to get. So if you'll see our original data, so what here it is young, false, false, good, and the original data is young, false, false. Okay, so now in this case, when this data is given to the classification model, so it has to give the class is no. Okay, so application is not approved. If it is giving you the class as approved, that means your model is not properly trained. Okay, the model is not properly trained. You have not taken enough amount of data in consideration towards to get good experience. Fine. So now in this case, the correct class is not approved. Fine. Little bit history that we require for the basics so that supervised learning. So supervised learning is something like this. A teacher is there in the class and he's teaching, he's demonstrating. So whatever experience he is having, that experience he is sharing with the student, and with that experience, students are learning. Okay, so that is a simple way to express what is a supervised learning. For supervised learning, we require some supervision. Someone will go guide us, and with that particular guidance, we will going to do certain things. It is just a classification is a seen as supervised learning from example. The examples are given. Let's say simple example. Like I will going to show pictures of dog and pictures of cat. So you know that from childhood your brain has trained accordingly. So the moment I will going to show you, you will say, okay, this is the picture of cat and this is the picture of dog. This is the way, because before that the supervision has been done on you. Yes, in the childhood, it has been told to you that this is the cat, this is the dog. So that supervision is already done by your parents or by the teachers. Fine. So what the supervision is all about are labeled with predefined classes. So that is the important over whenever supervised learning you want to do. So at that time you require a data, and that data must be with a predefined are labeled with predefined class. Classes are already discussed. Just whenever new data comes, we have to categorize in which particular class it belongs. So it is like a teacher, the example which I have given. And moreover, the test data are classified into these classes. So whatever the test data you will supply after the building a model, okay, so it will going to categorize, yes, this is not approved or it is approved. So for that, what we require the label data. Fine. But in the real world scenario, most of the time, 30% time you will going to get a label data, and most of the time you will not going to get the you will have the unlabeled data. So if unlabeled data is there, what to do in labeled data is there, you are already knowing that supervised learning you can apply. Further, there are two steps in supervised learning. Okay, there is a process. So that process we need to understand. First process is a learning, which is also called as a training. We have to train the model. which is called as a testing. Once your model is trained, your model is matured, that time we can test. So what exactly a learning means? Learn a model using the training data. So you have to have some set of training data so that your model will learn out of that. So how to get that training data, that we'll see. Then there is a testing. So testing the model with unseen test data. Okay, that is very, very important. Whenever your model is ready and you want to test for the particular input, so that input must be unseen. The model will going to give the unbiased accuracy. The accuracy will be in that case, whatever the accuracy will be get achieved, which will be really the actual accuracy. Okay, if it is a known one, categorize okay properly, but if it is unseen, okay, that is unknown scenario has been given, so at that point the model need to categorize correctly. Okay, that is exactly the accuracy we can say. What is accuracy? Number of correct classification divided by total number of test cases. So whatever the number of test cases for which you want to check, based on that you can calculate the accuracy. With this figure you can easily see we have to follow two steps. The first step, training, where you will have the training data which is totally separate, then which will be get applied on the learning algorithm. Okay, once it is applied on learning algorithm, your model is ready. Once your model is ready, you will going to apply the test data. Is altogether separate, okay, which is not the data from this which was already trained. Okay, so the trained data will not be the part of testing data, right? And then after the testing, we can record the accuracy. Okay, so more the accuracy on the test data, we can say the model is good, right? That is one of the measure, but here we're going to see more and more measures. There are more than only accuracy is not only the measure, there are various measures that we need to see in this session as well. Now moving, what do we mean by learning? Means learning is what exactly it is, because supervised learning is all about how well the model learns. Okay, so let's say given we are having a some data set D, then we want to perform some measure the performance, okay, which is M. These are the given. Okay, so the measure can be accuracy, you want to accuracy. There is another measures as well that we will see after these slides. So the data set is given which is a D, some task we need to perform, and we need to record the performance of that as a M. So what your computer will do, a computer system is learn from D, perform a particular task T. After learning the system performance on T improves as measured by M. So once this task has been performed with respect to this data, and then if after learning the system's performance on T improves as measured by this M. Okay, M is the measured. Fine. So whatever the task, so let's say the task is categorize whether the loan application is approved or not. Yes. So first of all, on the data set, learning will take place. After that learning, I will going to check whether the new data is correctly classified or not. But what we can say, the learning model helps the system to perform better as compared to no learning. Okay, so no learning is not the solution. In no learning, statically we can see, okay, this is the application, okay, this is not the correct way, where the accuracy will be not good. So here we are taking the help of learning, okay, and through that learning we are trying to improvise the accuracy, the performance. Now moving further, example, suppose I am having a data which is a loan application data. Then the task here is predict whether a loan should be approved or not. That is my task. This task I'll repeatedly perform once I'll receive the new application. And what is my performance measure over here? I want to see the accuracy. Okay, I want to see the accuracy. So data is there, task is there, and I have decided that I'll going to check only the accuracy. Suppose you use a first approach which is called no learning. That means you don't want to learn anything from the data and directly you want to classify based on the future application and what you are doing over there. Majority of classes you are saying that they are approved. Okay, you are not doing any learning. Yes, you are classifying all future application, which is the test data, the majority classes. Majority classes, definitely in this case, it has to be yes, because for the bank, more and more loans is a given, more and more revenue they can get for the many number of peoples. So here the accuracy can be calculated 9 divided by 15, which is a 16%. So let's say there were 15 new applications, okay, that is 15 new test data, and out of that majority, let's say 9 are says that your application is approved, okay, without any learning. So here we get an accuracy of 60%. But this accuracy can be improved if we apply the learning, because in the learning what we do, we consider the past data, and on that past data the model keeps on learning, and it try to categorize that particular application whether it is approved or not approved. Moving further, there is a fundamental assumption of learning. Whenever we are making a learning, so learning will be done by classification model. Yes. So the assumption says that the distribution of training example is to the distribution of test example. So what happens whenever we are doing learning? So in the learning, we are making a two set. One is a training set and another one is a testing set. So when you are doing a training and when you are doing a testing, that particular set must be identical. Identical means it's not the same in size. Identical means it is the same in the features. The kind of feature the training example will have, similar kind of features has to be in the test. Then only your model will going to perform well. Okay. So it also says that including future unseen example. That means we here what we can do, here we can do some augmentation also. So by using that data augmentation, we can construct some future unseen examples. We can make the part of training example as well as testing example. Right? So this is the assumption that we have to make at the time of learning. But what happens in practice? This assumption is often violated to certain degrees, not for all data sets, but some of the data set this assumption is not applicable. But if there is a strong violation of this assumption, so you will going to get poor classification accuracy. The accuracy will be not good, because this is very well taken in terms of whatever the features that we learn, yes, from the training, and similar kind of features if you are having in testing, so your chances of having accuracy will be more. So to achieve good accuracy data, okay, because on the test data only I'm going to measure the accuracy. On the training data there is a no measurement of accuracy, it is just learn. Okay, so training example must be sufficiently representative of the test data. Okay, what training example we have, they must have the kind of sufficient representation. Okay, if data it's of no use, you will not going to achieve the good accuracy. This is very fundamental and very important. There is a one question. What is an ideal accuracy value for healthcare system? So now here, so in health, what the means, it is a cancer detection or it is a disease prediction. If that is clear, so I'll answer. So ideal accuracy, there is no any ideal accuracy. Like take an example of skin cancer detection. Fine. In skin cancer detection, your data set is image. Yes. So heart related problem. Okay. So in heart related problem, what you will do? You will going to see the symptoms. Yes. You will going to see the symptoms. Fine. With that symptoms, also you can do, you can have the knowledge of the experience the doctor has, that also the parameter based on whatever the parameter which we're going to select. Okay, because for heart related problem, what we have to do, what are the different causes which the heart related problems can occur, so those will going to become your attributes. Okay. Now in this case, you have to have amount of data set. If the sufficient amount of data set if you have, and you will make a classification model, and let's say new patient comes, okay, where it is giving the new data value. So if that will going to feed, so in that case, the way it was learned, because learning is all about experience. Yes. So the more and more data you will have. So in this case, heart disease prediction, what we can do, you can have the some different measures. The measure can be, there has to be a less false positive. Okay. The false positive has to be very, very less. Then only in that case, heart disease related accuracy which you'll get, that you say that okay, it is 90% or 80%. So there what you have to do, you have to select some threshold. Okay. So in the question is ideal accuracy. To have the ideal accuracy for the heart related problem, kind of a threshold. Once it reaches to that particular threshold, you can say the person will have the heart disease, otherwise it will not going to have a heart disease. Yes. So you got an answer. Yeah, thanks for your reply. Now moving further, now I'm going to see what are the evaluation of classic, evaluate that particular classifier. Okay, so classifier means your classification model. So these are the certain evaluation, the methods by which the once the model is trained, you can evaluate. So first thing is it can be a predictive accuracy. The predictive accuracy can be calculated like this: number of correct classification divided by total number of test cases. That already we have seen. Then another one is the efficiency. So efficiency is measured here in terms of time to construct the model. Okay? How much time the model is taking. Moreover, time to use the model. Use the model means once your model is ready, how much time it is taking to the response. Okay, to classify the data. So by that you can find out the efficiency. Then there is another one on which you can measure the robustness. So robustness talking about handling noisy and missing value. It is possible that the certain data set on which you are working, it is some noisy data is there and some missing values. So how you're taking care of that handling noisy and missing, that talks about the robustness. Okay, that means sometime so how that value you are going to fill, that can be decided. Fine. Then scalability is another important one. Scalability efficiency in a disk resident data set. That means your data set is very, very large, and that data set is getting accommodated on the disk. That means again you have to retrieve the data from the disk. So if it is scalability, just means based on whatever the data, that means you first of all you will get one instance of data, you will process it, okay, another instance of data, then you will accommodate this. Okay, so scalability means how scalable your model is in terms of to accommodate more and more data towards to learn. So more and more it learns, that means it is a scalable, and if it is more scalable in that, they definitely your model in turns towards to have the more accuracy. And the last, interpretability. The interpretability says that understandable and insight provided by the model. That means whatever the information which we are getting, whatever the results which really those results are insightful or not. If they are not insightful, we have to see what we have to see whether the data sets which we have chosen. Okay, because everything depends on the data set which you are choosing for the future prediction. So understandable, insight provided by the model. So if model providing proper information to you with respect to the data on which it has been learned, so we say that the model is interpretable, that also we can measure. Now moving further, Now I'm clear. My voice is coming. So, so the training data set will be for learning a model, and testing data set will be for testing the model. So that is the first thing that you have to do. Most of the time people are using different kind of percentage. Okay, it is not a count, it is a percentage. 80%, 20 is the separation most of the time people are utilizing. So training data set will be 80%, and testing data set will be 20%, so that you are getting enough amount of data values for learning. Yeah. Then there is a certain importance. The important is training set should not be used in testing, and vice versa. Testing set should not use in learning. So for testing, the data must be unknown. Okay, the data must be unknown. So unseen test set provides a unbiased estimate of accuracy. Okay. Otherwise, if whatever that has been that you are giving as a testing, so what will happen? You will get a more accuracy. After that, your model will not going to perform well. Fine. So that's why whenever you are unseen data, you have to provide so that you will get unbiased estimation of accuracy. Now moving further, the test data is also called as a handout set. Okay. So in this case, the example in the are the labeled with classes. So we are talking on supervised learning. So whatever the data set which will have to be labeled, and it must be categorized in the classes. So this method is mainly used when data set is large. Okay. So what we can get out of this particular slide, when your data set is very large, so that time you will going to have and you will going to have testing set. Only two sets are more than sufficient. We are having a different size of data. Yes. So some data sets are very large, some data sets are moderate, some data sets are very small. So for different types of data sets, we have to come up with a different approach or strategy in terms of training set and testing set. Fine. So this is the slide which talking about if your data set is very large, so you will going to have a training set and you will going to have testing. Fine. There is a question. Validation set is a taken from which set? So this is a disjoint. All are disjoint. Training set, testing set, and validation. They all are disjoints. Okay? Because validation is testing only. Right? So learning set will be not mixed with the validation. Testing set will not mix with the validation. They all are disjoint. We will going to come on the next slide on that. Moving further, evaluation method we want to continue. Let's say sometime we are applying n-fold cross validation. Okay, n-fold cross validation. What it says that the available data is a partition into n equal size disjoint subset. Okay, n equal size disjoint subset. That means you are having, let's say, a simple example to understand. Suppose you are having an array of 100, so you are dividing that array of 100 into array of 10, 10, 10, 10. So these are all disjoint subsets. Fine. You as the test set. Okay, so likewise we have to do. Suppose there are 10 subsets. So first of all, out of that, one subset will be a test set, and the remaining n minus will be the training set. Same to repeat for next subset. So that next subset will going to become a test, and the remaining will going to become a training set. So the procedure is run n times, which gives you n accuracy. Okay, so here this is a different data set. Whatever we have talked on the previous slide, that is for large data set. Right? We are dividing in the equal disjoint subset. Then we are one by one, we are taking one set as a test set, and the remaining will be training. Okay. Then here we are getting n accuracies. The final estimate accuracy of learning is the average of n accuracy. So later on, what you can do, you can average all these accuracies. Fine. And then you can declare this is the accuracy on the particular. So here most of the time 10-fold and 5-fold cross validations are commonly used. You can go beyond that also. It totally depends on how much data you have. And this particular slide speaks about this method is used when available data is not large. It is a moderate kind of data. So when you are having a moderate kind of data, So you can apply n-fold cross validation where you can have n equal size disjoint subsets. Okay. Now moving further, now when your data set is very small, okay, we'll see. So leave one out cross validation. Leave one out cross validation. What it says that this method is used when the data set is very okay. For different data sets, different uh, categorization has to be there in terms of testing and training. Fine. It is a special case of cross validation. It is a special case. Each fold of the cross validation is a single test. Okay. Whatever we have seen previously, there is a set of test examples, but here it is only a single test example will be there. Why? Because I am having a very small data set, right? And all the rest of the data is used for training. For example, to understand, suppose I am having a set, only 10 data values are there, okay, 10 records. So out of that, so 10 record means it is a very small data set. Yes. So one record will be going to become a test example, and the remaining 9 will going to become the training. They will be utilized for training. So if the original data has m examples, okay, so this is a m-fold cross validation. So here we have learned from these three. For large, we have to have this test data and validation data. That is a test data and the training data with respect to large size. Then for medium size, you can have disjoint subsets, and then for small size, you can have a single example as a test. Now moving further, validation set. Okay, this was asked by Jayapal. So what validation set is? The available data can be divided into sets. Okay, training set, validation set, and test set. These all are in this case a disjoint. Okay, there will be a no overlapping. Okay, there will be a no intersection of data among these three sets. Okay, so validation set is used frequently for estimating parameter in learning. So if you want to estimate the parameter at the time of learning, okay, so we have to use a validation set. It is helping you to get the best model. So in such cases, the best accuracy on the validation set are used for the final parameter values. That is the importance of validation set. Okay, and the last, cross validation use for parameter estimation as well. As you can use a cross validation that we have seen in the previous slide, getting good parameter estimated. Okay, moving further. Moving further, there are certain classification measure that is very important. Classification measure means accuracy is one. There are many. Those all we will going to see in detail. The previous class, that is much in the last 5 to 10 minutes, madam talked about recall, precision, accuracy. So that all we will going to see in this detail. And there are some more other parameters as well that is very important to understand, because based on that parameter we can record the performance. The first one is accuracy, and then the error can be calculated 1 minus accuracy. Yeah. So accuracy is not suitable for some application. That is also true. So then if accuracy is not suitable for some application, so you cannot measure the performance in terms of accuracy. You have to go with some another measure. Okay. So now here I'm having an example. In text mining, we may only be interested in the document of particular topic. Okay, so I want to do some text mining and I am interested in document of particular topic, which are only a small portion of bigger document collection. So you are having a bigger data set, okay, bigger documents, and in that just a particular topic you want to find. So in this case, accuracy will not be the good measure. You accuracy, yes. So classification involving skewed or highly imbalanced data. Whenever you are having a skewed or highly imbalanced data, let's say an example, network intrusion and financial fraud detection, we are interested only in minority classes. Yes, the minority classes are more important in that case, not the majority classes. Okay, because here what we are having, the data set is a skewed or highly imbalanced. Okay, imbalanced data set is there. Measurement is not the good criteria, but in that case we can be more interested in minority classes. Okay, so high accuracy does not mean any intrusion is detected. It is not like this. Okay, we are going in reverse way. So if you get a high accuracy, it is not that you are going to detect the intrusion. Example, 1% intrusion achieves a 99% accuracy of doing nothing. Okay, so I think this example is very clear. Here, so here what you can measure accuracy and just you can see what is the error. That error is very less. If error is very less, that indicates that your model is 99% accurate and that nothing is happening on that computer system. Now next, so we have seen that only accuracy is the not the measure. Then there are the different classes of interest. These classes of interest are very much important. What they speak about, interest is commonly called positive class and negative class. Okay, so this positive class is there with respect to the problem on which you are working. Yes, on which you are working. So it will be the other measures are precision and recall measure. So moving further, used in information retrieval and text classification. So whenever you are reading the paper on information retrieval and text classification, the researcher are calculating precision recall. They are not targeting on the accuracy. Okay, they are not, but the accuracy we can calculate. Yes, accuracy we can calculate. So we use the confusion matrix. This is the kind of a confusion matrix. By this confusion matrix, precision can be calculated and recall can be calculated. So here we are having actual positive, actual negative. Actual positive is represented in first row. Actual negatives are represented in second row. Okay, and then classified as a positive and classifies as a negative. Whatever that we are actually positive, they are positively classified or negatively classified. So with this particular confusion matrix, we can able to understand what can be precision and recall. So before we need to understand in detail what is a TP, FN, FPN. So TP stands for the number of correct classification. Here, this is talking number of correct classification of the positive example. Your example is positive, classification is correct. Moreover, FN, that means this indicates that incorrect classification of positive example. Okay, so this first row is talking about positive, second row is talking about negative. So false, FN indicates incorrect classification of positive examples. Then FP is talking about negative. So the number of incorrect classification of negative, incorrect. And then PN, it indicates that the number of correct of negative examples. This is the way this confusion matrix get generated over here. And in Keras library, direct function is there. That function you can call, and all this confusion matrix is. Moving further, the of precision recall is like this. So P precision, what it does, it is taking a true positive in this correctly divided by the P plus FP positive, all the positive, whether they are true positive or false positives. This is going to give the precision. This is your recall. So what this statement says that precision is the number of correctly classified positive examples divided by total number of examples that are classified positive, including false positive and including true positive. And recall is a measure of number of correctly classified positive examples divided by total number of actual positive examples in the test. Okay, this is a negative, this is a true positive. So just that you have to add, you will going to get the recall. So this is the way. So now in this case, what we want, this is very less. So this R will be more. In this case, this is very, so here you will going to achieve more accuracy. In precision, what we require to get a more precision. Get a more precision, we require the false positive must be very less. Similarly, here to achieve more recall, false negative must be very, very less. Okay, so in that way. Now moving further, take an example. Okay, so it will be more clear. Example says that actual positive, here it is 1, actual negative, here it is 0, classified negative, it is 99, and classified negative, it is 1000. By using this confusion matrix, which is generated by a particular precision, can be calculated 1100. You just see the formula of precision. For positive, in this case, it is 0. This is a false positive. See, this is 0, so your precision comes out to be 100%, and recall is only 1%. Because we only classify one positively and no negative example wrongly. Right? Now here there is a one note. Precision recall only measure classification of the positive classes. Okay, these are the two measures. They are only talking about positive classes. Okay, targeting more and more positive classes, less and less negative classes. Another measure which is called as a F1 value, or also called as F1. So when we can use F1 score, that we will see, it is hard to compare, to classify using two measures. Okay, so now we got two measures. One is a precision, another is recall. So by using precision and by using recall separately, it is very, very difficult to compare how that particular classifier is performed. So we can combine those particular results, which will going to become a F1 score in terms of precision and recall. So your F1 score information, the formula will going to become 2 times PR divided by PR plus 1, which can be written in terms of harmonic mean. Likewise, F1 score is equals to 2 divided by 1 by P plus 1 by R. So here, this is the harmonic. So we require the value of P and value of R must be as maximum as possible. If there are more maximum, then there is a chances to have this F1 score very, very large. Harmonic mean of two numbers tend to be closer to smaller of two numbers. So P and must be large. Where P and R, what is the P? Is a precision. R is a recall. If they are very large, then only you will going to get the F1 score is very, very large. So these are the different measures that you can see in different research paper. So based on the particular data set on which you want to work, so just you investigate or you see in the resultant discussion of that particular paper what kind of performance measure they are using, and you can use on similar, or if you want to use some other, so you have to justify in what way you are incorporating the new measure of performance. Now moving further, we are having some other measures which is called as receive operating characteristic curve. Receive operating characteristic curve. So the use of this particular curve, which is ROC curve, which is generally plotted. Sorry.
I mean, performance classification comparison.
Yes.
I mean, comparison. F1 has 0, and other mode has 0.8. So,
just can you repeat your question? I am not able to hear clearly.
Sir,
please repeat your question.
Oh. We are using F1 score as a measure. So
you can write it
classifiers based on the F1 score. How to decide the conclusion? Okay, okay, sir. Okay, sir. Okay, sir.
Your voice is cutting in between, so you put in the that, so that question will be clear, and then I'll answer for it.
Sure, sir. Sure, sir. I'm typing.
Yeah. Okay. So how to compare two classifier based on F1 score? One F is equals to 0.8. Okay. Another one is 0.9. Okay, fine. So now in this case, we'll move on that particular slide. See here, we are calculating this F1 square. Okay. F1 scale, what the statement says that it is hard to compare two using two measures. If you are using two measures, let's say first measure is a recall and another is a precision. So at that particular point, you have to target to one, because the precision and recall, these both are targeting to positive classes. Okay, so what you are they are targeting to positive classes. In your problem statement, you have to have less number of negative classes, then only this precision and recall will get increased. Yes. So now one score you got for the one class which is pointed, and another one. So these two are, one is F, uh, based on F1 score, one is F S 0 point other. Compare to classifier based. No. It is not like this. Compares based on F1 score. F1 score, here it is. The two means what exactly we are doing, like precision and recall. In precision and in recall, positive class we are considering more. That means what we want to do, we want to try to reduce the false. Uh, I'll move on that slide so it will be more clear. Yeah, I want to reduce this f of n. When this is lesser, this r will be more. And in this case, when p is lesser, so this p will be more. Yes. So for that, this is one measure and this is another measure. Then you will use that two measure and be an F1 score. Okay. So what it says that one is pointed another. You cannot get a you cannot get a two F1 score. There will be only one F1 score. Can you give the data set on which you have worked, so I will be more clearly answer this? On which data set you got this kind of exam results? Oh, one as 0.1, fine. And classifier 2, okay, two classifiers you are using, fine. So first one is 0.8, another one is a 0.2. So 8. So now having a two classifier, okay, the measurement is very hard. Okay, I cannot directly say that the mean of that will be the result. That means a 0.8 is the accuracy at that particular point. No. That the both I need to consider based on this particular formula, where it says that in precision false positive to be very less, and here false negative has to be very less. So with that I am able to get P and R, and then that P and R I can utilize over here to get the F1 score, and then here I can declare this F1 score is the measure. Okay, when you are having more and more classifier, so in combination whatever the result you will, okay, for classifier 1 and classifier 2, so you will get some recall and you will get some precision. So that recall and precision in combination you can utilize and you can get only one score. Okay, and that score you can say performance of your model. Okay, so there are other measures as well. So I'll stop at this point because uh, which is based on stress management. So I have just tried to cover only supervised learning. I have not touched the unsupervised learning, but still I'll going to share the PPT. So mean later on you can read from those PPT and you can get the idea. If any questions are there, I request to ask the question. So if any questions are asked,